In the last lesson, we learned about multiplying signed numbers, and in this lesson, we will use our multiplication fact families to help us understand how to divide signed numbers, okay? Much like there was a relationship between addition and subtraction, hopefully you'll notice a relationship between multiplication and division. In example number 1, it says to write 2 multiplication and 2 division sentences using the following integers. We're going to use 3, 5, and 15. Okay, we're going to write 2 multiplication problems and 2 division problems using these numbers. And let's start with multiplication. Okay, if I look at these numbers, I know that 3 times 5 is equal to 15. Okay, and remember that multiplication is a commutative operation, so I can reverse the 3 and the 5 and write it as 5 times 3. And again, I'm going to get an answer of 15. All right, now, what division problems are related to these multiplication problems? Well, remember that division is the inverse of multiplication. So if I take the answer to the problem, the answer was 15, and I divide it by one of the integers, let's divide by 3, 15 divided by 3, I have to get the other integer that was involved in the multiplication problem. If 3 times 5 is 15, then 15 divided by 3 has to equal 5. Okay? Similar to that, again, if I start with 15, and this time if I divide by the 5, then again I'm going to have to get my other integer, which was 3. 15 divided by 5 is 3. Okay? From our results, we can see the first rule of division. All right? Both of these problems show the first division rule, that if we take a positive number and we divide it by another positive number, then our answer will be a positive number. A positive divided by a positive is positive. In example 2, we're again going to write 2 multiplication and 2 division sentences, this time using the integers 6, -3, and -18. Okay, so let's start with the multiplication problems first. If I take 6 and I multiply it by -3, all right, well, we learned last time that a positive times a negative is a negative, and 6 times 3 is 18. So there's one multiplication problem using these integers. And again, remember, multiplication is commutative, so let's switch that around to -3 times 6. And again, a negative times a positive is a negative, and we'll get -18 for the answer. Let's come up with 2 division problems related to these multiplications. If I start with the answer, which was -18, and I first divide it by 6, okay, well, again, I've got to get the other integer in the problem, which in this case is -3. And here is another new division rule that I can write down here. If I take a negative number and I divide it by a positive number, then my result, my quotient, is going to be a negative number. Okay, a negative divided by a positive is a negative number. Okay, let's write down one more division problem. Again, if I take -18 and I divide it by, let's do the -3 this time. Well, again, I've got to get the other integer that was involved in the multiplication problem. -18 divided by -3 has to equal +6 because of the fact family. This gives us a third rule that we can write down. Again, if we start with a negative number, and this time if we divide it by another negative number, a negative divided by a negative will give us a positive quotient. A negative divided by a negative is a positive. We're going to look at one more fact family to help us with a fourth division rule. In this example, again, write 2 multiplication and 2 division sentences using the integers -8, -2, and +16. Okay, so let's start with the multiplication. So if I take -8 and -2 and multiply them together, we learned last time that a negative times a negative will give us a positive, and 8 times 2 is 16. Okay, now using the commutative property, -2 times -8, well, again, a negative times a negative, that's going to give us a positive product. Let's see if we can come up with some division problems now related to these multiplications. If I take the answer, which was 16, And let's divide it by negative 8 first. 16 divided by negative 8. Well, then because of this fact, then my answer must be negative 2. Or if I start with 16 and I divide it by the negative 2, well, again, because of this fact family right here, then 16 divided by negative 2 is going to have to give me negative 8. Okay, from your results, you know the final rule of division. Both of these problems show the same division rule, that if we start with a positive number and we divide by a negative number, okay, well then our quotient is going to be a negative number as well. A positive divided by a negative equals a negative. Hopefully you've noticed that multiplication and division follow a similar pattern. Let's see if we can review these rules. Okay, so these are the product or quotient rules, meaning for multiplication or division of signed numbers. In letter A, if the two numbers involved in a multiplication or division problem have the same sign, so both numbers are either positive or both numbers are negative, then the result gives us a positive number. A positive number. Okay, so a positive times a positive is positive, a negative times a negative is positive, and it works with division as well. A positive divided by a positive is positive, and a negative divided by a negative is positive. In letter B, though, if the two numbers involved in the multiplication or division problem have different signs, so one of the numbers is positive and the other one is negative, then the result is a negative number. Okay, so a positive times a negative is negative, a negative times a positive is negative, and then with division, a positive divided by a negative is negative, and a negative divided by a positive is also negative. We're going to talk about a couple more important things that are related to division. The first being dividing the number 0 or dividing by the number 0. Okay, they sound similar, but they actually mean different things. If you were dividing the number 0 by a number, okay, for example, like 0 divided by 4, okay, I'm taking nothing and I'm dividing it into 4 groups, the quotient will always equal 0. Okay, if you take nothing and you divide it into equal groups, no matter how many equal groups there are, there's still going to be nothing in each of those groups. So if you're dividing the number 0 by a number, the quotient will always be 0. Now, if you are dividing a number by 0, so in this example, maybe it's 4 divided by 0. Okay, well, if I have 4 things and I tried to break them into 0 groups, well, you can't really do that. The smallest you could do is divide it into 1 group. Okay, you can't take something and divide it into nothing. If you're dividing a number by 0, the quotient will always be undefined. Undefined, okay? We call that undefined. Okay, and in fact, if you were to do this with a calculator, if you take any number and you divide it by 0, it might give you some sort of an error. It might say that it's undefined. Okay, it cannot be done. So you can't take something and divide it into nothing. That would be undefined. But if you take 0 and divide it by a number, then you will always get a quotient of 0. The last thing that I want to talk about relating to division is the placement of the negative symbol. We've talked about a few rules with division that involve negative numbers, and we want to talk about where the placement of that negative symbol is. So looking at these 3 fractions, okay, they all look very similar, and I want to know, are the following quotients equivalent? Okay, so we have negative 18/4, we have negative 18 divided by 4, and we have 18 divided by negative 4. Okay, this first one I'm going to save. I'm going to come back to this one. I want to talk about each of these because we've already talked about examples like this with our division rules. In this middle example, we have a negative number being divided by a positive number. Okay, and when we do a negative divided by a positive, we learn that the quotient should be a negative number. Okay, and now if we do the division, 4 goes into 18 4 times. 4 times 4 is 16, so there's still 2/4 left over. So this becomes negative 4 and 2/4, which actually simplifies down to negative 4 and 1/2. In this last example, we have a positive divided by a negative. We learned before that a positive divided by a negative will be a negative number as well. Okay, they have different signs. When we divide numbers with different signs, the quotient is negative. And again, it's 18 divided by 4. 4 goes into 18 4 times with 2/4 left over. So that also equals negative 4 and 1/2. So I know that these two are equivalent to each other. Are these both equivalent to this one here? Notice that the negative symbol is hanging out front. When the negative symbol is out in front of the fraction like this, it's understood to be the number negative 1. It's negative 1 multiplying the fraction 18/4. Negative 1 multiplying the fraction 18/4. And if we did this division, 18 divided by 4, well then this is just going to be negative 1 times 4 goes into 18 4 times with 2/4 left over. And now if we do this multiplication problem, a negative times a positive is a negative, and 1 times 4 and 2/4 would just be 4 and 2/4. So this comes out to be negative 4 and 2/4, which again is equal to negative 4 and 1/2. Okay, so notice all three of these give the same result. They were all equal to negative 4.5. So when you're doing the negative symbol, it doesn't matter where you put it. You can either put it out in front of the fraction like this, or you can put it in the numerator like this, or you can put it in the denominator like this. The important thing to remember is that there's only one negative symbol. It can go out front, in the numerator, or in the denominator. When I'm doing problems, I'll probably write them like this first example or the second example. I really don't like to put the negative symbol in the denominator, although it will give an equivalent result. Okay, so just remember the placement of the negative symbol. It can go out in front of the fraction, it can go in the numerator of the fraction, or it could even be in the denominator.